Hi there, Manuel here with a fresh and Tagma tutorial. Today I want to look into how to export effects from Houdini to Blender Eevee to render there. Blender Eevee is, as you probably know, the real-time rendering engine included in Blender 2.8 that was released in late 2019. And me personally, I think it is gorgeous, so why not check out how to render stuff there. We want to create a simple effect, cutting open a human skull model today, to then export to Alembic and render in Eevee. So let's directly dive into Houdini and start. To start, lay down a geonode and call it skull. Skull. For this tutorial, I provide you with a skull scan model that is part of my iExteria project. That is, or that will be a 3D scan library, 3D scan online library. If you're interested in this stuff, you can follow us on Instagram. It's not released yet, but I will post news there. So dive into this skull object and lay down a file node. And then let's import this iExteria beta skull object. And here you have it. And now let's append a null. Call it out. And make it visible, like so. One level up. Let's create another geonode, and let's call this one bool. And the effect will happen inside of this node. I'm going for this two-node approach because I want to see the skull while I'm working on the bool, and that is the easiest way to do that. So dive inside of the bool object and switch this little drop down here to show all objects, and you will see the skull although you are inside of the bool object. So let's lay down an object merge and point to the skull out node that we just created. And now even if I go here to hide all objects, I have the skull. But I want to go back to show all because now I want to lay down a grid. And I make the grid visible and now I see both. So I have a large grid here. It's too large. So go down to 0.5, 0.5 in size and 2 divisions will do. And we want to use that one to cut the skull open. So let's append the transform here. And now let's transform this grid. Let's rotate it like so. And then a little bit along the X to the front like this. And this will be our cutting plane. So move it over such that it barely touches our skull. Like so. And now I want to animate this grid through the skull and later use it inside of a Boolean operator to cut the skull open. But it is cumbersome to animate it like this because we have all these uneven numbers here in the transform. What we can do is we can open up the pre-transform, that is just a second transform, so to speak, and then copy this parameter, paste it down there, but in this case we don't paste relative references, we just paste the values. Same for rotate. Copy the parameter, paste the values down there. And now everything is messed up. But if I now zero out stuff up here, like so, we end up with the same transform. But what we now can do is just animate the Y translation here, very clean, to move our plane in this local Y direction. And that is what we intend to do. So let's go to frame 1, and by alt-clicking into this Y field here, let's lay down a keyframe. And then let's go to this Global Animation Options dialog, and let's go down to 50 with the end frame. 50 frames is enough for our animation. Let's go to frame 50, and now move the grid over such that it does not touch the skull from the other side, like so, and set another keyframe by alt-clicking. Now we created an animation of this grid through the skull. At the moment it's eased because Houdini automatically eases animations, but we want a linear animation, so shift-click on the translate keyword here, and this will open up the timeline. And if we make it a little bit bigger, you see the easing that happens on this track here. So let's select both keyframes and then press this little linear icon up here. And that will transform this to be a linear animation. So now we are going linearly from start to finish. To be able to do a bool, we need a volume or a closed 3D object, and we just have a grid. So lay down a poly extrude and append it to the transform. And now let's dial in a little distance here. If we go to the last frame, you exactly see how big this has to be to encompass the entire skull. Well, something like that. And let's turn on output back. And now we have a closed 3D object engulfing our skull. But this slightly blue color indicates that the polygons are reversed. So we are looking at the backside at the moment. So let's fix this by appending a reverse sub. And now everything is nice. On the other side, this skull comes with predefined normals. But as you can see, they are using a threshold angle. And to fix that, let's append a normal. And let's go up with this cusp angle to 180, like so. Great. Now it's time to lay down a bool. Boolean, first input will be our skull, second input will be our extruded grid. And if we now go to frame 23, say we have the Boolean operation in place. At the moment, I see both sides of the Boolean operation, and that is, remember, because we see the skull through. So if we temporarily switch to hide other objects, you see it is cutting open this skull. Great, but we are not only interested with the intersection part, but we want this cutting plane too. So let's tick on the output primitive group A inside B. That is all the primitives that are inside of our extruded volume, and that can be used to separate out the polys inside and this cutting plane. And let's do that. So let's lay down a blast here, and let's use this group A inside B, and that is this cutting plane. So let's delete non-selected, and we end up with just the skull part, and then just copy over this blast and turn delete non-selected off, and you end up with this cutting surface. But if you look closely, this cutting surface is all black, and it's just one n-gun, and for Blender it's better to have triangles. So let's lay down a divide to refine this polygon, like so. And now we have a lot of triangles, and check avoid small angles, which gives cleaner results, and don't generate slivers like so. And now we can lay down a normal too and append it here, like so. Okay, great. So that is our cutting surface, and this side here is our skull. Time to export out this stuff to Alembic. Let's append an Alembic ROP. ROP Alembic output and connect it here, and just set the file path. And I'm going to my HIP directory, create a new folder called Geo, accept, and in there I want to export skull ABC for Alembic, accept. And then switch the valid frame range from render current frame to render frame range. That goes from 1 to 50, and just press save to disk. Now that this is written out, let's repeat the process. So another Alembic ROP, but on the other side. Again, switch to render frame range, and this time, inside of the Geo folder, we call it cut.abc, and that will be the cutting plane, and again save to disk. Okay, all done. Time to switch to Blender and bring the stuff in. So here we are in Blender. I'm running version 2.81a. That is currently the latest version. First, let's get rid of the default cube. Just click it and press X and then delete, and it is gone. And then File, Import, and Alembic. Let's go to our Geo folder, and let's open the skull ABC. You can click on this little arrow here to get some settings. Scale is 1, relative path, set frame range, all good. Press import alembic. And you come up with this bool object here. That is called bool because it is named after the object node in Houdini. And if you look closely, you see this little thing, and that is the first frame of our animation. And you see it brought in the alembic. And because the skull is real world size and Blender units are in meters, this is quite small. Double click it to name it skull. Like so. And now same process again, import alembic, and this time let's import the cut. And let's call it cut, like that. So now we have a skull and a cutting plane. And it is animating just like in Houdini. Okay, let's click the skull and then control click the cut and then press G and you can transform. And if you now press Z, you can constrain your transformation to the Z axis. I do that and move the skull up a little like that. Good. Now let's apply a texture to the skull. So select the skull object, and like Houdini, Blender is using panes. To create a new pane, you click in this little corner here and drag over, and that generates a new pane. And with this menu here you can switch to another pane type, and we need the shader editor. And we don't have a material set yet. So to do that, go to this Material tab and press Use Nodes, and that will give us a principled BSDF, so a principled shader and an output node. That is what we need. And we want to bring in the textures that come with the skull to apply them to the skull. And we can do this by drag and drop. So just open up your directory in Explorer and drag in the albedo map, which gives you a texture node. And then repeat the process for the normals, which gives you another texture node. So we end up with 2 texture nodes. The normals have to be interpreted differently. At the moment they are set to sRGB, but this is data, so we have to switch it to non-color data here. The albedo can be sRGB, which is fine. To create a normal map node, you don't press tab like in Houdini, but Shift A to bring up the search, and then just type normal and create a normal map node. So this normal map texture goes into this color port, and the normal goes here into the normal port. You don't see anything happening, and that's because we are on the preview view mode. But if we switch over to Eevee, you see that we now get something, and it takes some time to read in the texture, and then we can navigate around it. So here's our normal map, and if we now connect this albedo to the base color, we get a color too. And here's our skull, and it is animated. Great. So now let's give a texture to this cutting surface. Select the cut, go again to materials, press new, and you get another principled BSDF, and I just want to set the base color to something bluish, like that, and then give it a little subsurface scattering. So just scroll over here to give this a little bit of an effect. Like so. Okay, to render this, I want to put it on a seamless background. Let's quickly model that seamless background. For that, we don't need the texture editor anymore. So if you go to this divider line, you can right click and then just choose join areas. And then you get an error, what to join to what. So we want to join over like this, and we end up with a 3D view. Now let's introduce a box. Let's press Shift A again, and that creates this menu where we can choose to create a cube like that. If we want to edit the polygons, we have to go to edit mode, and that is what Blender put on the tab key. So if I press the tab key, I'm entering edit mode, and up here you can choose which component to select. We want faces. Click outside of the object to deselect everything, and then just select these faces. And to delete them, press X and then choose faces. And we end up with just these 2 faces. Now, we wanted to create a subdivision surface out of this to create a seamless background. And for that, we need another edge loop. So go to this loop cut tool. And once you see this yellow loop, click and drag to place the loop cut. Same on the other side, like so. Now, leave edit mode by pressing Tab again. And now we want to apply a subdivision surface modifier. And that is done here in the Modifiers tab. So first let's call this seamless and then add a modifier subdivision surface, which gives us this. Up the viewport subdivision to 2, but it is rounded and we don't want that. We can fix it if we enter edit mode again. And now go to edges and to the select tool and just select all the edges around the object. And we want to crease them. So select them all, then right click and then choose edge crease. And as soon as you choose that, you are in sliding mode, so to speak, or in the slider mode, and you can just move your mouse to increase the creasing. Increase it until everything is sharp. Now leave edit mode by pressing Tab again. And the last thing is that it is shaded faceted. And we want to shade it smooth. So right click on the object and choose Shade Smooth. And now we are left with a nice seamless object. The origin of this object is sitting here at the origin of the world, this little yellow dot. But we want the origin to sit here directly on this plane. So let's move up the entire thing by pressing G, then constrain it to the Z-axis by pressing Z, and then just press 1 on your numerical keyboard to move it up exactly 1 unit, and then press Enter, which moves the entire thing 1 unit up. And as the standard cube in Blender is 2 units, this will put the thing exactly on the ground plane. And now we can move the origin back to the world origin by going to Object, Set Origin, Origin to 3D Cursor. And 3D Cursor is this little red and white thing here. Okay, now we have an object that sits exactly where we want it. And now let's give it a shader. Go to the shader editor again, press New, and then we can just dial in the color directly from here because it mirrors all the parameters here in this interface. So let's give it something purplish, like so. And that is our base setup. Now for the lighting. First we need an environment. At the moment we don't have one. So we need the shader editor again. Create it. Shader editor. But this time we want to change the environment shader. And at the moment it is showing us object shaders because this drop down is set to object. Switch it to world. And this shows you the world output and a background shader. And we want to load in an HDR. So press Shift A again and then search for environment texture. And press this open button and navigate to our texture folder. And here I have an HDR that I downloaded from SIBL. The link is in the description. And I choose Barcelona Rooftop 3K HDR. And once you have that, just connect it here to this color input. Take some time to load. And you see that we now have this HDR in the background and it automatically lights our object. So the object is now lit, but it's a little dim. So I want to change the gamma on this HDR and then I want to multiply it a little up to make it stronger. So first press Shift A again and search for gamma. And just put the gamma node here in between the two, like in Houdini, and change the gamma to 2, like so. And now I want to lay down a mix RGB node and put this here after the gamma. And I want to change the factor to 1 to have the full effect, and change the operation to multiply. Now it's multiplying our HDR with the second color, and if you click here, you see the color is gray. But if you click here, you can set it to 1.5, which makes it a little stronger, like so. Now let's rotate the HDR. To rotate it, we need a mapping node. that can be used to transform the texture coordinates. At the moment, it is using the default texture coordinates, but as soon as I connect this, it is not using them anymore, but it is relying on this input, which is 0. So we have to provide it with the default texture coordinates, and that can be done using the texture coordinate node. And that has a generated output, which is the default texture coordinates. If I now connect this, I can change the orientation. Remember that Blender is Z up, so rotating around Z rotates the panorama. So go to minus 68-ish, like so, to have light from the right side, like so. Okay. Sometimes in Blender, the navigation gets hard. You see that I'm barely capable of navigating anymore. To fix that, like pressing space H in Houdini, select your object and then press the period key on your numerical keyboard, which resets all the clippings and stuff. Now you can navigate again. Okay, now we have light in our scene, and by default, Blender comes with a default light. Turn this off for a second and you see just the effect of the HDR. But the skull is very light inside because the HDR light is going through. And to fix that, let's turn on ambient occlusion. To do that, go here to the render settings. Here the render engine is already set to Eevee. And down here you have all the effects of Eevee. And turn on ambient occlusion. And that will create ambient occlusion, giving a far better result immediately, as you can see. Okay. Now for the light, we want to use it, turn it back on, click it, and then go to this light tab. At the moment the light is set to be a point light, but we want to use a spot. So click spot and the light is up there. By pressing G, we can move it over. And to here. And if we want to rotate it, we can just press R and rotate it. Like so, and that will light our skull very intensely. So let's dial down the color to something bluish, like so, and let's go down with the power to 300 watts, like that maybe, and let's see what that gives, and that looks quite nice. Okay, now for the shadow. The shadow is very, very soft. You can set the softness of the shadow, or if shadows are soft, here in the render settings under shadows. And you see first you have the resolution of the shadow maps, and down here you have soft shadows. If you tick this off, you just end up with hard shadows, but we want soft shadows, and we want to up the cube size to 2048, which gives crisper shadows. And by the way, these soft shadows are created by offsetting the light a little bit. And in the viewport here, it's doing this 16 times, and that is determined by the viewport setting here, 16. If you render out, it uses 64 samples. If you want to see how this looks, you can set this to 64 here, and you see that the shadow quality increases. Very good. Like so. Maybe we want to rotate the light a little more to the back and move it over again, like so. Something like that. More rim lighting, like that maybe. Because we want this dual tone light, having the warm light from the HDR and the cold light here as a rim light. Something like that. And now we want to set our camera. To set the camera, we first need a camera, but the Blender default scene comes with a camera. Here it is. And at the moment you're looking through the editor camera. You're not looking through this camera. If you want to look through this camera, press 0 on your numerical keypad. And you will enter the camera, which is very far away. If you now try to navigate, you're not navigating the camera. Instead, you are zooming this camera frame here. To navigate the camera, you press N to show the settings for this view, and then under View you can lock the camera to the view, just like in Houdini with a little lock icon. And once I check that, I can now navigate my camera, and the camera will update from whatever I do here in the viewport. So Let's zoom in here. But we want to render out a square format. So let's go to this tab, which is the output settings. And at the moment, the output is set to 1920 by 1080. So let's set it to square, 1920 by 1920. It updates automatically. And we can update our viewing angle like so. And whenever you disable this, you are changing this camera frame again. By pressing 0 on the numpad again, you are entering the editor camera, and pressing N again will hide this panel. And we can move our light a little over, then enter the camera again, because I want this shadow here in the background. Let's do this again. This shadow edge should be visible, and our object here is a little too small, so let's move it over like so, and let's enter our camera. And that is pretty much what I was looking for. So let's position our camera like so, and let's test our animation. Very nice. That is what I was looking for. Great. So now let's render this out. To render this out, you go to this output tab again. Down here you can choose the file format, let's say PNG, and now a location where to render to. Let's go to our folder, create a new folder called render. Dive inside, and let's call this skull. Accept. It is set to 24 frames, like Houdini was, and the start frame is 1 and 50. And now that you have that, you can just go to the render menu and say render animation. And it will open a very large window, because it is rendering 1920 by 1920. Can make this smaller. And by going to this view menu, you can set it to frame all fit, and it will scale down the image to fit this window, like so. And now you can render it out. Let's wait for the animation to finish. Okay, great. It finished rendering. So let's look at what we created. Let's go to our render folder, and here you have the rendered result. And to view this, I'm using DJView. So just drag the first file into DJView and make this window a little smaller. And here is our animation. If you want to make it look even nicer, go back to Blender, and let's go to the skull again, switch the shader editor to object, and let's give the skull a little subsurface scattering by just setting the subsurface to 0.002, say, which gives it a little subsurface. And then we can go under the rendering tab here to color management, and the color management is using the filmic transform. And at the moment the look or the view transform is set to none. We can set this to medium high contrast, which gives it just a little bit more contrast. Maybe it's a good idea to move the light over a little bit, because at the moment it shines directly into the skull, and that is probably not optimal. So if we just rotate this a little bit, move it up there, this looks a little nicer, like so. Maybe even reposition the final frame a little bit, and all of this happens in real time. So iteration is very quick. And that is a very, very brief intro into how to render with Eevee in Blender. I hope you like it, and for some tasks it might be the solution. So thanks for listening, and see you next time. Let me say a very big thank you to all our patrons. Without you guys, this would not be possible. Especially to Patrick Fillon, François Baillargeon, Encore VFX, Important Looking Pirates, PU Online Learning, Rafik Anadol, Christopher Hebert, and Nathan Wilson. Thank you so much for supporting us, all of you.